All right, so let's see about getting this powered up. Now I know because 16 years ago I tried to power this up and I found a problem, and the problem turned out to be with the power brick. And these power bricks are notorious for failing now, and they're notorious for being potted. You can't take them apart. So what we're going to do is we're going to get into the power brick and we're going to fix it. This power brick is kind of unusual these days. It has a 9-volt AC supply, which is used to run the cassette deck and also for some timing for the sound chip called the SID chip. And it also has a 5-volt supply, which is what runs most of the rest of the computer. I looked it up, and the 5-volt supply is 1.5 amps. Fortunately, these days, getting a 5-volt 1.5 amp supply is pretty easy. We can just grab any old USB dongle that can put out the required amperage. All right, here's a little closer look of the power supply. And one really fortunate thing about my power supply is that the wires did pop up out of the potting before they went into the cord. So what I did years ago is I cut them and labeled them and hooked them up to a temporary power supply. So let's go ahead and, just for fun, let's see what's going on with the built-in internal power supply. Maybe it's fixed itself. So what we're going to do is we're going to go ahead and plug it in. We are live. So these two cables that are exposed are the going out to the computer. They go out to this DIN. But the blue cable here and the brown cable here are the ones coming out of this power supply. So you can probe these 2 points, and look, we're getting 4.992 volts. So it looks like this power supply is working just fine now. Or is it? Now here's the thing. Just because we're getting 5 volts doesn't mean we're getting any current. This is an unloaded power supply. And so what you could do is, if you were doing something like this at home, you could get something that takes 5 volts, like an LED with a resistor or something else, and you could hook it up and see if it works. I've got a little bit fancier toy here. I've got this cool little tool. It's an electronic DC load by Arachnid Labs, and since I have it, I'm going to use it. So what I'm going to do is I'm going to go ahead and take these 2 probes, and I'm going to hook them up to the power supply. And right now there's no load enabled, so shouldn't nothing too exciting should be happening right now. So we'll hook that there, and looks like the blue wire might be a little harder to get a hold of here. Let's see if we can do this without having to strip it off. It might have a connection there. Okay. All right, and you can see here we currently are set at 0 milliamp load, and we're getting 4.99 volts, which is what we were seeing on the multimeter. So let's go ahead and give it some load. So we'll start off very slow. 10 milliamp load. We're set for 10 milliamps, and we're loading at about somewhere around there. It's kind of bouncing there, but look at that, we're getting some voltage drop already. Let's go ahead and go up. So 10 milliamps is enough to kind of run an LED, but not really. 20 milliamps, that'll run an LED pretty good, but we're already dipped down to 4.5 volts. Go to 30 milliamps, we're dropped all the way to 4.2. 40 milliamps, 4, and just keeps getting worse. Look at that. Now I looked up the spec on the Commodore 64, and it's rated for a maximum of 1.5 amps. So it's not going to pull that all the time. That's probably with like a million accessories plugged in, the data cassette being powered, everything else. But you know, I think, you know, being able to hit a third of that should be a goal of our power supply, and we're currently below a volt. So just because we're getting 5 volts unloaded doesn't mean our power supply is good, because as soon as we put a load on it, it just goes away. And you know, I struggled with this concept for a while, you know, trying to understand what some people call stiffness of a power supply. And then it kind of dawned on me one day, you can kind of think of a power supply as holding, you know, the voltage is 5 volts off the table. So it's a kind of, you know, unit of measurement of I'm 5 volts above the table. And this is what our power supply is doing right now. It's 5 volts above the table, but it's nothing, you know, there's no load, there's nothing on it. If I start adding weight, say this 9-volt battery, I start to dip a little because, you know, I'm a weak power supply. And if I added a whole bunch of batteries, you know, eventually I get pushed all the way back down to a volt, just due to the weight. So that's kind of how to explain what's going on here. It's you know, we're able to put out 5 volts with this power supply, but you put it under any type of load and it just falls. So that's not going to work. So what we're going to do is we're going to go ahead and hook up a USB cable in place of the 5-volt rail to these 2 wires, and then we'll take a look and see how much power that provides. Okay, so we went ahead and hooked up a USB cable and USB adapter up to our DC load. And you can see that we're currently getting 5.18 volts with no load. So we're 5.18 volts above the table, but nothing's loading it down right now. So let's go ahead and give it some load here. Look at that, we're already at 20 milliamps and we haven't dipped below 5 volts. So let's just keep cranking this up. There we go, 180 milliamps, just dipping below 5 volts now. So, you know, the hand is struggling a little with the weight, but it's not dropping too bad. Let's take her up to about 500 milliamps. Yeah, 4.62 volts. I'm thinking that's probably strong enough. If it turns out that that's not enough current for the Commodore, we can swap out this brick with a beefier one. But yeah, I think it'll be fine. Let's see if we can actually do the theoretical max. Let's see what happens here. This will be a good baseline if we have problems in the future. So 1.5 amps, we're only getting 3.24 volts. But I bet, you know, that's probably just a quick spike thing. Actually, we can do that. We can simulate that. We'll do now is I've set the output or the input of the electronic load off. So it's not actually loading the power supply right now. You can see we got 5.19 volts at the bottom right there. So what I'm going to do is I'm going to flip it on and then off again, and we'll see if maybe we can have a higher voltage for a split second. Yeah, you can see it dipped down to 4 point something for a second before it completely collapsed. So I have a feeling that, oh wow, it was holding 5 point. Look at that, it's actually doing better now. Oh wait, we're off. Never mind. So yeah, I think we'll be fine with that little supply. But the nice thing about USB is if this isn't beefy enough, it's not warm at all. If it's not beefy enough, we can always get a different brick. I'm just going to make sure that I don't get a brick that's too overpowered, just because I wouldn't want it to fry the whole computer if something in the computer itself goes bad. So what I'm going to do is I'm going to go ahead and solder this up and make it look nice, and then we'll be back. So I'm going to go ahead and solder on this bench so that you guys can see what I'm doing. I'm not sure how exciting this will be. But what I'm going to do is I'm going to use some zip ties and some flex loom just to, you know, tidy it up, keep it looking nice. So what we'll do here, we'll probably try to do a lineman splice or a telegraph splice. That way if there's any force put on this, it'll keep it from pulling apart. I don't have the original back cover to this power supply. I believe I must have yanked it off when I was trying to get it working back in the Y2K days, and who knows where it went after that. All right, so there's our power supply. It's looks somewhat stock from this angle. Added a little bit of strain relief here. So all we gotta do is plug it in, plug in our Commodore. I'm really tempted to do it. I want to do it right now, but I'm gonna go ahead and do some quick checks on the Commodore to make sure that when we plug it in, we don't blow it up and let all the magic 1985 smoke out of it. So I'm just gonna go off camera from in here and grab the Commodore. All right, so here's our Commodore. And what I'm going to do is do some quick tests just to make sure that it doesn't blow up when we turn it on. If I recall, it's pretty easy to get into. Actually, it looks like it's missing its screws. So that's a bummer. Oh, we got another sticker here with the serial number, but unfortunately no date. So let's go ahead and do some quick tests here. Since it's already unscrewed, I guess we could just, oh wow, there we go. And I think there's some plastic tabs on here if I recall correctly. So we need to make sure I don't break those. They seem to be doing a pretty good job of holding things together without the screws. I don't know where I'll find, I'll have to look on the internet to figure out what kind of screws I need to put back in this thing when I'm finished. So there's the keyboard cable, there's the LED cable. I think I can unhook the LEDs. That was a 3-prong and it's polarized, so that's nice. Won't have to remember how to plug that back in. And it seems like it's coming apart. It's a little stubborn over here. Looks like last time I took it apart, I might have pried with a screwdriver. Oh, funny story. When I was younger, I had a pencil on the table. It rolled across the table and hit one of these joystick ports here, and blew the fuse in my Commodore 64. And I remember I had to take it apart. That might be when I made these marks back here. So you know, a little, probably 10, 11, 12, and freaking out because I had blown up my computer. But I took it apart and there was a big obvious fuse on the right hand side, if I recall correctly, and I didn't have a fuse, but fortunately my disk drive had a fuse, an externally accessible fuse on the back, and so I was able to steal the fuse out of that and get the Commodore powered back up, and heaved a big sigh of relief that I hadn't completely destroyed it. Alrighty, look at that, 1983 Commodore International. So we'll see, here's some capacitors. I don't see anything leaking out of them. We can try to test them in circuit and see how they look. There's that fuse I was talking about. So that thing had blown up, and I remember being super relieved that that was the problem. It looks like we've got some more electrolytics kind of scattered around randomly. I don't know if I'm patient enough to test all of these, and I won't be able to know if they're really. God, look at these regulators. They've got. Oh, this is crazy. There's regulators on the board, but they're not actually touching the board. They're not even screwed in. I wonder. I wonder if that's missing its screw. This one's not screwed in either down here. Maybe they decided they didn't need that. But yeah, I'm not seeing any capacitors that have barfed everywhere. This, I believe, is a transformer. The 9 volts comes into this transformer here, and it gets stepped down, and then I think it pulses over to the SID chip, which is, I think, one of these guys. I think it's that one, actually. And I think that helps with the timing. That's why the Commodore sounds different in the US versus the UK, is because of the 60 hertz versus 50. This over here, if I recall, is the memory. I think these are the ROMs. I'm not sure what the rest is. So this chip here is socketed. Let's take a look at that. We'll just go through the chips. That says CBM on it. Commodore Business Machine. Or Business Machines? Yeah. So those, and then we have The RAM chips over here. So here's what made it a Commodore 64s because of the 64K RAM. Actually, I guess we should sweep them this way. And what are those? 15 nanosecond? I don't even know. Let's see. Okay, and so in here, this is actually no, this is the RF can for the TV. But I've heard that there's a bunch of capacitors in here, and it's actually required for the Commodore to work. So hopefully nothing's gone boom in there. And then I think the CPU is under here. This is like a combination RF / heatsink, although I've heard that it doesn't really perform as a heatsink very well. But we can go ahead and look into that later. What I'm interested in right now is the power supply over here. So there's the power supply. What we're going to do, let's just set up our camera here. So what I'm going to do is I'm going to make sure that the power's off, and it was on, so now it's off. And what I'm going to do is I'm going to plug in our repaired, I hope, power supply, and we'll try to take some voltage readings off that and see if everything looks sane before we go turning this on. So let's go ahead and hook up our 9-volt AC. And actually, let's just plug in with the 9-volt AC and see if we can find that. And then we'll go hunting for the DC. So right now the DC is unhooked. We'll turn our multimeter on. Okay, so let's go ahead and see if we've got anything on those AC lines. Now I'm not sure where the AC comes in. I can look it up, but I'm just going to probe around. It'll be faster. And we're going to make sure our multimeter is set to AC. Not used to doing that. Okay, let's just try these two big obvious ones up top here. Something's happening. There we go. We got about 10 volts AC. That's, it's supposed to be 9 volts, but it's unloaded, so that's not too surprising. So I'm going to guess that these other two connections are probably supposed to be the DC. Yeah, there's nothing really there. So what we're going to do is I'm going to go ahead and switch us over to DC mode on the multimeter. And I'm going to plug us in. Now remember, the Commodore's turned off, so there shouldn't be any load on here. So we might see a bit above 5 volts, hopefully. And I'm seeing absolutely nothing. So that means that either our repair didn't work, or I'm not on the right pins, which doesn't seem likely, but it's possible. Oh, well, that's interesting. I'm getting 5 volts on the outer shell. Let's go ahead and test the pins here. Now, if I recall, it's these bottom two pins, and this is going to be really hard to get in camera. So I'm not going to do that on camera, but what I'm going to do is I'm going to measure these two bottom pins. Alright, we're getting our 5.1 volts on the two bottom pins. But when I plug it into the Commodore, two bottom pins of this connector, I wasn't getting anything. Nothing. But if I touch the shell of the connector, it's almost like the outside shell of the connector is where my positive 5 volts are. Maybe this... Oh, look at that. I'm getting... So both the bottom pins are giving me negative voltage, and the shell is giving me positive. That is really weird. Well, maybe that's how this thing worked? I don't know. It's really weird. I'm not sure what's going on with this connector. Maybe that's normal. I guess what we can do is we can hook up some video and power it up and hope for the best. So what I'm going to do is I'm going to go ahead and unplug it first. and close it up really quick. Okay, and now this is the reason why it's taken me so long to get back to this project and why I'm so excited now. There's no way for me to really plug this in. You know, it's designed to be plugged into a television, and I don't really have a TV that takes that kind of connector anymore. But fortunately, there's a community out there of wonderful people that are still making brand new products for the Commodore 64. And I got this great thing from Retro Computer Shack. It's a Commodore 64 S-Video cable. So I'll be able to plug into this connector that I never got to use as a kid. And I'll be able to get S-Video out of this, which is great! Except I don't have anything that takes S-Video. But a quick trip over to Amazon netted me this little VGA to S-Video adapter. And so I've got it plugged into a spare LCD just for testing. I might hook it up to a tube later. We'll see how things go. So let's go ahead and get this hooked up and see if our Commodore lives. This cable is really nice too. Alright, so that didn't go completely according to plan. I guess it's kind of exciting though, because that means that we really do have another problem other than just the power supply. I think getting 5 volts positive on the outside shield of this power connector is probably not a good thing. So what I'm going to do is I'm going to go ahead and do my homework on the internet and find out a little bit more about how the power comes into the Commodore and do some more testing, and I'll be back with another video. But I wanted to get this one out there for now. We did meet several goals that I had for today. So we found out it was made in October of 1986, which means I got it in for Christmas in 1986, which means I was 11 years old at the time. So that was cool to find out, and I'll be hopefully back with some more, and we'll have it up and running, and then I can show you some other fun surprises that I have in store. Thanks for watching.